Hi, this is Turali, and the topic that we are going to cover today is going to be projection systems. Now, as draftsmen, it's extremely important to know what are all the different types of projection systems and what they mean. So when we look up here, this is where it all starts, called as projection systems, and it is split in two. One is called as the perspective projection, and the other one is called as the parallel projection. Throughout this whole class and the whole course, we will be covering all of these different projection systems that we see over here. We are going to look into perspective projection, the different types of perspective projections that we have, and when we go on the right, we are going to look into parallel projection, the different types of parallel projections we have on this side as well as this side, and even on this side. So when you look at the blue color, all these are parallel projections. They fall in that branch, but it is still part of the projection systems. So first we are going to finish all these different types of parallel projections in our course, and then we will jump to the perspective projections at the end of the course. Now we have to understand a couple things. First thing, what does it mean by parallel projection? Parallel projections have lines of projection that are parallel both in reality and in the projection plane. So for example, if I were to make an object, all my projection lines would go parallel. So I have a cube, and it has a hole right over here. So if I were to make all my orthographic projections or multi-views, which is the top, front, right, left, I would start with, this is my front, this is my top, and I have, this is my side. And on the side I have an opening that's like that. Okay, so now if I were to make the front view, my front would just look like this. Now I would project my lines to make my top view and the side view. Okay, so what happens in parallel projection, when I'm projecting my lines would go parallel to my object. Okay, so my top view would be here somewhere, and my side view would be here somewhere. So now you see the lines of projections are all going parallel to each other. So that is why it's called as parallel projection. So if I look from the top view, all I see is this shape. And if I were to make the side view, again, all my lines are projected parallelly, so I know exactly where it falls. So my side view will look something like that. Okay, so this is parallel projection where the object lines are projected parallel to each other. When we get to the perspective projection, they do not run parallel to each other. So that is one main difference that we have to remember. Okay, so let's see what are the different types or branches in parallel projection. So on the left over here we have oblique projection, on the right we have orthographic projection. Orthographic projection is the one that we use the most, where we make the front view, the top view, the side view, the bottom view, and we try to explain our drawing to the contractor, to the designer, to the engineer, to the construction company, so that they can look at that drawing and they can manufacture or construct the object. So the orthographic projection is further divided. It's also called as the multi-view projection because again we have 6 different views. As I said, top view, front view, side view, right side view, left side view, bottom view. So there are 6 different projections, and they're even called as multi-view. If you go down further, there are 2 different types of multi-view projection. One is the first angle projection and the other is the third angle projection. Now the main difference between these two is just how you place the drawing on the sheet. Now in the US, we use the third angle projection, but pretty much the rest of the world uses the first angle projection. Okay, so that's one thing we have to remember. The only difference between those two is just how the drawing is placed on your sheet. It's just like we use inches over here, and the rest of the world uses the metric system where they're using meters and centimeters, but over here we use feet and inches. So same thing we have as the first angle projection and the third angle projection. All it is just how you place the drawing on your sheet. So now let's look at the difference, starting with the US. Now this is what a front of an object looks like. That is how the top view of the object looks like. So the front is over here in front of you, and the top is always on the top, and the side is always on the side. So that's an easy way to remember. But if you are in the rest of the world, the top view always comes first, and then on top of the top view you have the front view and then the side view. So basically what we have in these two, the main difference is it is just reversed. Okay, so if you are working for a project in the US, you will place your sheet drawing like this. If you are working in China or in India, you would place your drawing on your sheet like this. Now if you can look in this example, this is the front view, side view, and the top view. You see how the lines are projected from the front to the side and from the front to the top. See how they are projected? So all these lines are parallel to each other, and that is why they fall in parallel projection. Okay, so parallel projection orthographic projection and oblique projection, two different types. In orthographic projection are also called as multi-view projections, where we have 6 different projections, where we have the front, top, side, we could have the bottom, we could have the left, so we can have 6 different types of projection. And on the other hand, or on the other side, we have axonometric projections. So orthographic projection is split into axonometric projections and multi-view projections. Now axonometric has isometric, dimetric, and trimetric. Now if you look over here, this looks like 3-dimensional. And if you look over here, this looks like 2-dimensional. But there is one thing in common, and that is the projection lines that you see over here as well as over here. Okay, you see this? All the projection lines are still parallel to each other. So if I were to make a simple cube, I would draw my projection lines. And see, I would draw my projection lines, and they should be parallel to each other. So this line is parallel to this line is parallel to this line is parallel to that line is parallel to this, is parallel to this one, and this is parallel to this. So if I were to put this one in here, how would I do it? I could just use this part, the top step. So all I'm using over here is parallel lines, and I'm using that as my guides. Now again, the shape would differ if the object is a different shape. This is the easier shape, but when we get to learning how to draw isometric views, then we'll see exactly how to draw and learn the different axonometric projections, which is isometric, dimetric, and trimetric. So I just made this one over here using parallel projection lines. Okay, same thing goes with dimetric and trimetric. So there's one thing we need to know: difference between axonometric projection and multi-view projection is multi-view projection is 2D, where you have the top, front, right, left, bottom view, just like what you see here, and axonometric projection is in 3D. This is what it looks like. Now axonometric projections are mainly used to explain the drawing, because a lot of people have problem understanding the object by just looking at the multi-views. So that is why, to explain it to the client, you would make a 3D object, which is an axonometric view, and it makes it a lot more easier for him to or her to understand the drawing. Now in parallel projection, we even have oblique projection, which is, I would say, a combination of axonometric and multi-view projection. Why? Because it does use the multi-view projection, where one of the surfaces is either in the front or the top, like what you see over here. This is a box in the front view, and then all what we have given over here is given it a depth, just like what we did over here, gave it a depth. Okay, but if you see the front over here, the front is at an angle. Over here the front is not. Okay, now let's show you one example. For a cabinet projection. So for a cabinet projection, I'm going to make an example of a desk. Okay. Just a simple desk. So this is the front view, and I'm going to project it using my parallel projection. So this is going to be the top part of the desk. Okay. Just going to make it a little bit darker so it's easier to see. Alright, so we have the front and we have the top view. I can even have the side view. But again, if you're looking side view, we're looking this way, right? So all we are looking is the side of our desk. Now if I show this to the client, if he understands projection system, he can easily understand this, but sometimes he doesn't, and I would like to make a quick oblique view, and that is really easy when it comes to oblique projections, because we are going to be using one of the principal views, and all we do is give it a depth, and that will make it look 3D. So I'm going to take this and just giving it a certain depth. So what we have over here is a cabinet oblique projection. And how did we get this? We just started with the front. We just started with this front. And we just gave it a depth. That's all we did. And see how easy it was? It just took a minute. And why is this called parallel projection? Because again, all the lines are running parallel to each other. See, this is parallel to that. That is parallel to this. This is parallel to that. That's parallel to that. This is parallel to this. Now the only difference between cabinet projection and Cavalier projection is cabinet projection has a depth which is half the actual size, while Cavalier projection has a depth that goes the actual size. Now the only reason why we use more of a cabinet projection is because it looks more realistic. Okay, so this is your oblique projection, cabinet projection. If I were to make the same thing using an isometric view, first of all, I couldn't just start with my front view. I would have to start at an angle like that. Alright, so you see the difference between the two? This is isometric view of this table, and this one is a oblique view of this table. So the front is straight, over here the front is at that angle. So I hope we understood all the different types of parallel projections that we have. Orthographic projection, this is the one that we use in draw, used for construction and manufacturing drawings. Axonometric projection, which is isometric, diametric, and trimetric, used for presentation, trying to explain our drawing. Oblique projection, again used for explaining the drawing, where you would convert it into a 3D. This is 3D. Axonometric projection is 3D. Multi-view projection is 2D. What falls under multi-view projection? All the 6 different projection systems. At the same time, we have sections that are drawn using multi-view projection. We have auxiliary views that are drawn using multi-view projections. But we'll see more of that when we get to those chapters. Okay? Now the next one that we have over here is perspective projection. Perspective projection is primarily for making 3D perspective views. Again, this is just mostly used for presentation. They are not used for construction, they are not used for manufacturing. Now the main difference between these two is you will see the projection lines. The projection lines in perspective views are not going parallel to each other. They are merging at a point. So if I were to draw a cube, when I'm using parallel projections, remember, all my lines were running parallel to each other. Okay, like if I'm doing my isometric view, all my lines are running parallel to each other. But if I were to draw the same cube using perspective projection, my lines would merge at one 2 or 3 different points. Okay, so maybe one point is here, one point is here. Again, this is merging on that point. This is merging on this point. So you see how the cube looks like? It looks different from the one in the isometric view, because over here the lines are merging towards the vanishing points. So we'll get more into this when I will teach the chapter for perspective projection. But right now all you need to know is how is perspective projection different from isometric projection or oblique projection. Okay, so this is perspective. And if I were to draw the same thing, same cube using oblique projection, it's really simple. I have one of the views, which is maybe the front view, and all I do is give it depth, and all the lines are running parallel to each other. Alright, isometric projection running parallel to each other. So perspective projections are 3 different types. One is called as the 1-point perspective, second one is 2-point perspective, and the third one is 3-point perspective. As the name says, when we say 1-point perspective, the object projection lines are vanishing towards one point. When we say 2-point perspective, just like the example that we did over here, so the object lines are vanishing towards the vanishing points, which are 1 and 2. Okay, and when we get to the 3-point perspective, see the object lines are vanishing towards 1, 2, and 3 vanishing points. That's the main difference between 1, 2, and 3-point perspective. Again, when we get to the perspective chapters, we'll be doing perspective drawing, then we learn how to use all these 3 different techniques. There's something called as aerial perspective, which is used mostly in architecture companies, where you will make a perspective view of a building. It could be either linear or it could be aerial. The only difference is linear is mostly when you take it on eye level, and aerial is mostly when you are higher up above on the ground, like a bird looking down at the house. So I hope you understood what are all the different types of projection systems, and like I said before, we are going to cover all these chapters. We are going to cover parallel projections, orthographic projections, all multi-view projections, the first angle projection, third angle projection. We are going to have a chapter on axonometric projection where we learn how to draw isometric, dimetric, and trimetric. We are going to have a chapter on oblique projection where we understand what is cabinet projection and Cavalier projection and how to draw using these two different techniques. We'll have a chapter for perspective projection where we learn how to draw a house using a linear perspective as well as an aerial perspective. We are going to see what are the three different types of perspectives we could use: 1 point, 2 point, or 3 point. Like for example, in this house you see over here, the lines are vanishing, that's going towards 1 point. The lines are vanishing, that's going towards the second point. So this is a 2-point aerial perspective view. Okay, so the next chapter I will be working with is going to be orthographic projections, where we will cover multi-view projections. Thank you for watching.